So today we're going to be talking about specific heat again, but this time quantitatively. So we're going to be using our equation Q equals mCp delta T. Remember that Q was the amount of heat gained or lost, and that's always going to be joules or calories or kilojoules. It's only going to have one unit though. That unit is a unit of heat. M is going to be mass. It's generally going to be in grams, but you could also see milligrams or kilograms or centigrams. Delta T is our change in temperature. We're going to do the final temperature minus the initial temperature. Most of the time it won't matter which one you're subtracting. You'll just make it a positive number. But if you're solving for initial temperature or final temperature, you'll need to make sure that you're plugging it in like this, final minus initial. And then Cp is our specific heat capacity. Remember, it has 3 units. Our unit of heat over grams degrees Celsius. So wherever you see Cp, you're going to put the number and the unit of heat, and then grams degrees Celsius goes opposite of it. So in this problem, it says how much heat, so if I'm looking for heat, that's going to be Q, is required to raise the temperature of this many grams, so that must be mass, of water from this to this. So my delta T is final minus initial. So first I'm going to calculate that. So I get 13.4 degrees Celsius. I'm looking for heat, so I don't need to rearrange because it's already set to heat equals. Just like we've done before, we're going to set it up with dimensional analysis so we can make sure that our units are canceling. So my mass is 530 grams. My Cp, this is water. Since it's water, that's the only Cp that you needed to recall. We want the joule Cp of water, which was 4.184 joules per gram degrees Celsius. If it wanted calories, I would have used 1 cal per gram degrees Celsius. I don't have anything on the bottom of my equation, so Cp's on top, so 4.184 joules goes on top, and my gram degrees Celsius goes on bottom. Finally, I'm going to plug in my delta T, which was 13.4 degrees Celsius. I'm going to cancel and make sure that everything cancels out. So grams and grams, degrees Celsius, I'm left with joules. I want joules, so now I must be done. I just need to multiply across. In the calculator, I get this. I have 3 sig figs in my mass, so that's what I'm going to look at. When solving these, don't look at your temperature for your sig figs. So we want 3 sig figs. So that's 1, 2, 3. So that's 2, 9, 7, and then 2 zeros. I also could have written it 2.97 times 10 to the 1, 2, 3, 4 joules. Let's look at one more together before you practice. So it says calculate the mass, so I'm looking for M. This I can use for my delta T. So 45 minus 25.2. And then this is joules, so that must equal my Q. I'm looking for my mass. So to get M by itself, you have to isolate it. So I'm going to get rid of everything else that's next to the M. So divide by Cp delta T. Cancel, cancel. So my rearranged equation is M is equal to Q over Cp delta T. I'm going to plug my Q in on top. So 25,000 joules. I have Cp and delta T on bottom. Cp, though, has multiple units, so I'm going to use the separate box over here. So I'm going to go ahead and plug my delta T in. So it doesn't matter where delta T goes on the bottom, as long as it's on the bottom. Just like the previous problem, we have water. Remember that water Cp was 4.184 joules per gram degrees Celsius. But in this problem, my Cp is on bottom. So the 4.184 joules goes on bottom, and my gram degrees Celsius goes on top. I'm going to cancel my units. Joules cancel. Degrees Celsius cancel. I'm left with grams. They wanted their answer in grams, so I must be done. If they wanted kilograms or centigrams or milligrams, I would just do one extra step to convert that. Remember, when plugging this in, I'm going to do 25,000 divided by 19.8 divided by 4.184. So make sure that you're plugging that in and that you're getting the correct answer that we have on the board. So the calculator gives you this along with some other numbers. My joules has 2 sig figs, so my answer should have 2 sig figs. In this problem, I have a 0 as my second sig fig, and it doesn't round up, so the only way I can get that to 2 sig figs is if I convert that to scientific notation. So 3.0 times 10 to the second grams. All right, go ahead and pause the video and try this one on your own. Give you a hint, notice that these are not canceling, so you'll have to have an extra conversion in your setup. So you have the mass, you have Q, and you have CP. The problem wants you to calculate the delta T, so to get delta T by itself, you're going to have to divide by M and CP. So delta T, or change in temperature, is equal to the heat over mass CP. So my heat should have went on top. My mass should go on bottom. And then CP goes on bottom. So wherever the CP is where the number and the unit of heat goes. Opposite is where the mass and the temperature is going to go. Make sure you're always canceling units. So in this case, only my grams cancel. These two do not cancel, so I need that extra step. To get rid of joules, I need it on the bottom, so they're opposite of each other. And calories has to go on top, so again, they're opposite of each other. Like we've learned previously, 1 calorie is equal to 4.184 joules. So then calories cancel, joules cancel, and you're left with degrees Celsius, which is my change in temperature. When plugging it in, remember that you should be doing 31,000 divided by 120 divided by 0.2 divided by 4.184. So I get this in the calculator, but this has 2 sig figs, so again I'm going to go with 2 sig figs. This time my second sig fig is a 0, but that 8's going to round it up, giving me 310 degrees Celsius. Go ahead and pause the video and try this one on your own as well. Restart when you are done. So we don't know the CP. We know the mass. We know the Q. And we need to calculate our delta T. So subtracting those, we get 83.2 degrees Celsius. In the problem, we're trying to solve for CP. So to get CP by itself, we're going to have to get rid of M and delta T. So CP is equal to Q over M delta T. Our Q was our heat, which was 27,500 joules. Our mass was 45 grams. And our change in temperature is what we calculated a few seconds ago, 83.2 degrees Celsius. Notice in this problem, none of our units cancel out. It also didn't specify what they wanted their specific heat in, so I don't need to convert my joules to calories. So I'm just going to do 27,500 divided by 45 divided by 83.2. I get this. This number has 3 sig figs, but my mass only has 2 sig figs, so that's what I'm going with. So 1, 2, 7.3 joules over gram degrees Celsius, because again, none of my units canceled out. So this one is calculating the initial temperature. So make sure that you star this one or write this example down, because this is the one that people struggle the most with, solving for initial or final temperature. All right, so we have our mass, we have our CP, we have our Q. We also know our final temperature. We're looking for initial. I would suggest for this one, go ahead and just solving for your delta T. So to get delta T by itself, we need to get rid of mass and CP. So change in temperature is equal to my Q over mCP. So my Q was 83.8 calories. My mass is 54.9 grams. And my CP is on bottom, so my 0.380 joules goes on bottom. Gram degrees Celsius goes on top. I cancel my units. Grams cancel. These two are not canceling, so I need an extra step. I'm trying to get rid of the joules, so I put joules on top. I'm trying to get rid of calories. Calories should go on bottom. Remember that 1 calorie is equal to 4.184 joules. So now my calories cancel, my joules cancel, and I'm left with degrees Celsius. So my change in temperature is equal to, I need to multiply 83.8 times 4.184 divided by 54.9 divided by 0.380. So plug that into the calculator. So I get this in the calculator. We're going to go ahead and put our answer in 3 sig figs. So at this point, we can go ahead and round. It says calculate the initial temperature of a piece of brass when the heat rises to a final temperature of 134. So that means that my temperature to start with must have been less than 134 because the heat rose to that temperature. So 134 minus 16.8 gives me 117.2 degrees Celsius as my initial temperature. If you want, you can also just write 117 degrees Celsius. If the problem had said that we had cooled a piece of brass and therefore it released that many calories and the temperature dropped to a final temperature of 134, then we would have added those numbers and saw what the temperature was before the temperature dropped due to the brass. So when you're calculating temperatures, make sure that you're reading carefully to see if you should be adding it or subtracting it from the value that they gave you.